Hello and welcome you all. Dear students, today's topic is FFT algorithms. This is for the subject Digital Signal Processing. First of all, FFT stands for Fast Fourier Transformation. Obvious question is how FFT is faster, or from the exam point of view, the question can be like this: prove that for n is equals to 32, FFT is faster. This value of n can be anything. What is n? N indicates number of samples which are contained in the input sequence for which you are calculating DFT. So for example, n is equals to 32. We need to prove that if you are calculating DFT for n is equals to 32 and if you are calculating FFT, what's the difference? And then it will prove that FFT is faster. Apart from that, we'll be studying how to solve numericals as far as FFT algorithms are concerned. So we'll be solving the numericals on both the types. There are two techniques in FFT algorithm. One is called as DIT-FFT. DIT stands for decimation in time. Decimation means splitting or dividing. So this is DIT-FFT algorithm. Another algorithm is DIFFT. DIF stands for decimation in frequency. So in one algorithm we will be decimating, that means dividing the sequence into time domain. In another, that is DIF, will be dividing the sequence in frequency domain. FFT stands for Fast Fourier Transformation. One more term that is applicable for FFT algorithms is radix 2. Meaning of word radix is base of algorithm. This is related to binary, so base of algorithm is 2, so it is called as a radix 2 algorithm. So this can be also said that it is a radix 2 FFT algorithm. Alright, so if the question is consider n is equals to 32 and calculate computational complexity. What is computational complexity? Computational complexity means how many number of multipliers and how many number of adders are required. This numerical is very simple. If you just memorize these four formulae, and it's also simple, so you can solve such type of numerical. So if n is equals to 32 and if I am not performing FFT, I am using DFT, then these are the two sets. One is complex multiplication. Why the word complex? Complex means the things can be like this: 2 plus 3j. Whenever j term is there, it is called as a complex. So complex multiplications are given by n square, complex additions n square minus n. So if I am saying n is 32, simply put the values. So answer of first part, that is complex multiplication for DFT. If you are not using FFT, using DFT, it will be 1024. And complex additions required for DFT is 992. Simply you have to put the values and solve it on the calculator. On the contrary, if you are using FFT algorithm, then these are the formulae: n by 2 log n to the base 2. Do remember, log base of this log is 2, it is not 10. So log n to the base 2. So simply again, if you put the values, n is equals to 32, then this answer is 80, and number of complex adders, formula is n log n to the base 2, it is 160. So it itself proves that, this calculation itself proves that if you are using DFT, then 1024 complex multiplications are required, whereas only 80 complex multiplications are required. Same thing is for complex additions. For DFT, 992 complex additions are required, while if you are using FFT, 160 complex additions are required. So the required number of calculations are drastically reduces. That's why FFT is Fast Fourier Transformation. Now, about the algorithm, we'll solve few numericals to get an idea for these algorithms. See, I will be covering two types of numericals. As such, all the types of numericals that are expected, that can be asked for FFT algorithms. So do watch the video till the end so that you will be in a position to solve any type of numerical related to FFT algorithm. Consider one numerical using DIT-FFT. Calculate DFT of x of n is 0, 1, 2, 3. Let us say this is the given sequence. It is known as 4-point DFT, calculation of 4-point DFT. This is the given sequence. one more variation. 4 samples are given. If suppose 3 samples would have been given, like suppose the given sequence is only 1, 2, 3, like this. We need to make its length. Length means number of samples in the sequence equals to 4. So add a required number of zeros. One sample was remaining to make the length equals to 4. So I have written 1 0 at the end. Likewise, presently given sequence contains 4 samples, so it is okay. So given sequences are samples are 0, 1, 2, 3. From the given sequence, I will write the values like this. X of 0 is 0, x of 1 is 1, x of 2 is 2, x of 3 is 3. From the given sequence, I have written these values. Now, very important part. You need to memorize this diagram. This is called as the flow graph for IFFT, decimation in time algorithm. To memorize this diagram, very simple trick. See, one such block is responsible for calculating 2-point DFT. One such block is called as butterfly diagram. Butterfly diagram. This one block calculates 2-point DFT. So there are 2 stages. Let us say this is stage 1 and this is stage 2. How to memorize the diagram? See, if it is DITFFT, only you need to remember this sequence. It is x of 0, x of 2, x of 1, x of 3. It is not in the proper order. It is not like this x of 0, 1, 2, 3. It is x of 0, 2, 1, 3. Whereas final output is in the proper order. This you need to remember. Now, there are only, since it is 4-point DFT, 2 butterflies are required. So I have drawn 2 such diagrams. As I said, one such diagram, one such hardware circuit is called as butterfly diagram. So 2 such stages are required. There are only cross connections, nothing else. Similarly, stage 2, again there are cross connections like this. Okay, that means these 2 diagrams of first stage I have combined it simply by making a cross connections. Now, another thing, what about these values? How to memorize it? See, in the stage 1 there are 2 blocks. First block, second block. Every block represents butterfly diagram. At the end of each line, I have written -1. In the second stage, again there are 4 lines. 1, 2, 3, 4. In the last 2 lines, I have written -1, -1. Very simple. And one very, very important part. At the output of these things are called as adders. At the output of last adder in the first stage, don't forget to write -j. Actually, it is the value of W4 raised to 1. But we are not interested in notation. So simply I have written -j. Now, if you just memorize this diagram, you can solve any type of numerical related to calculation of 4-point DFT. Consider the present numerical. How to do it? See, as I said, these are only cross connections. Output of stage 1, I have written it as S0, S1, S2, S3. As I mentioned, if you draw this diagram, you are in a position to solve any numerical. Now, how to do it? So, first I will do the calculation of first stage. So, I am talking about first stage. Everything is related to diagram only. For first stage, first output is H0. So, here I will write H0. Observe the connection. To generate H0, H0 is the output of first adder. This adder I am talking about. Which lines are connected to this? This is the first line which is connected to this first order adder whose output is H0. And this is the second line which is connected to first order. What is at the input side of first line? X0. For this line it is x of 2. So simply I will write H0 is x of 0 plus x of 2. I have written the values. X of 0 is 0. X of 2 is 2. So it is 0 plus 2. Answer is 2. Same way, S1. What is S1? S1 is the output of second adder. This output. Again, for this adder, check the connections. Which lines are connected for this adder? I am talking about this adder, which generates S1. So for this is one line which is connected. I am making it, drawing it with the red pen. So this is one line which is connected, and this is the second line. So it is x of 0 plus x of 2, but this contains -1 sign. So I will write it like this. X of 0 minus x of 2. Why minus? Because this x of 0 is directly connected. x of 2 is getting multiplied with minus 1 and then it is connected to this adder. Output of this adder is S1. So it is x of 0 minus x of 2. In the exam, if you again forget this, just write down first equation, put a minus sign in between. That will be valid equation for S1. So very simple. It is 0 minus 2. It is equals to minus 2. Next, same way we have to do the calculations. S2. Look at this diagram. For S2, again check the connections. For S2, this line is connected. S2 is adder of output of this adder. Which is this line? It is X1. Which is another line? This line. What is input for this line? X3. So very simple. S2 is X1 plus X3. Refer the values which we have written. We have written these values for X of n. So X1 is 1. X3 is 3. 1 plus 3 is equals to 4. Last output of first stage, S3. Again refer this diagram. For S3, check the connections. S3 I have written over here. This is the output. This line is connected as well as this line is connected. These two lines I need to consider. Now, X1 is directly connected. X3 is getting multiplied with minus 1. So it becomes minus X3. They are added. So this thing can be written as X1 minus X3. X1 then X3 into minus 1. So X1 minus X3 and output of this adder is multiplied with minus j. This is the common mistake. So don't do this mistake. Output of last adder is getting multiplied with minus j and then S3 is obtained. So I will write it like this. This is X3 in the bracket. That means output of this adder and it is multiplied with minus j. So I will write it over here. It is X1. Sorry. It is X1 plus X3. It is X1 plus X3, but it is minus sign. So I will write it minus X3 into minus j. So X1 minus X3 into minus j. See, this is X of 1, X of 3 into minus 1. So minus sign. X3, it is multiplied with minus j. So this answer becomes X of 1. Check the values. X of 1 is 1 minus X of 3 is 3. 1 minus 3 into minus j. 1 minus 3 is minus 2 into minus j. Minus of minus become plus. So answer will be 2j. This is the output of stage 1. On the same lines, now I have to write the outputs of stage 2. So I will remove now this part because it is nowhere required. Now for stage 2, I need to make use of these values. These are the values for output of stage 1. For stage 2, you need to refer this diagram. So if you now don't need stage 1 because we have completed the calculation of stage 1, simply I am removing this diagram of stage 1. It is now nowhere required. This is now remaining diagram for stage 2. Now, same way, first output is x of 0. How to do this calculation? X of 0 is equals to, look at the diagram. It is S of 0, H0. Then next connection is this line. It was like this. It is S2. For this line, output is S2. So it is H0 plus S2. This line is S2. H0 plus S2. So I will write the equation H0 plus S2. For this, I need to make use of this calculation. So it is H0 plus S2. That is 2 plus 4, which is equals to 6. Second, X of 1. Same way. For X of 1, this S1 is directly connected, this line, and another thing is S3. This part is same as S3. So S3 is connected, this line I am talking about. So X of 1 is S1 plus S3. S1 plus S3. Refer the earlier calculation. S1 is minus 2. S3 is 2j. So minus 2 plus 2j. Then X of 2. Again we will refer this diagram. What are the connections for X of 2? X of 2. The connections are this line. This line is for S0. Same point. H0. So this line I am talking about. This line. And one more line is connected. This one. This line. So it is S0, then S2, and it is multiplied with -1. So it is H0 minus S2. So it is H0 minus S2, which is 2 minus 4. I am referring these values. H0 is 2, S2 is 4, which is -2. Last output, x of 3. Again refer the same diagram. For x of 3, this line, I have removed this earlier stage. So this was S1, same point. So it is S1, then S3 into -1. So I will write it as S1 minus S3. So value of S1 is -2, value of S3 is 2j, so it is -2j. How to write the final answer? Final answer is written as a sequence. That means I will write final answer like this. X of k is first answer of x of 0. It is 6. Second, -2 plus 2j. Third, -2. Next, -2 minus 2j. And simplest trick, whether your calculations, how can you check whether your calculations are correct or not? Whatever j term is there, the complex conjugate of this j term must be present in the answer. This is -2 plus 2j. So there must be one term containing minus of 2j. This is the last term. So these calculations are correct. So this is the answer of the sequence. X of n is equals to 0, 1, 2, 3. We have obtained using DITFFT, that is decimation in time algorithm. Now we will solve the one more numerical related to second algorithm, that is DIFFT. The next algorithm is DIFFT. Just now we solved one numerical related to DITFFT. Second is DIFFT. Same logic is there. Do remember some basic things. It is DIF, that is decimation in frequency. Earlier it was DIT, decimation in time. And time and frequency are reciprocal of each other. So I have drawn same diagram. You need to remember. Only I have changed the position. Stage 1 and stage 2 are interchanged. That's it. You don't have to memorize the diagram separately. And one important difference. Here, the input is in proper order, like x of 0, 1, 2, 3. Whereas output is shuffled. X of 0, 2, 1, 3. Remaining all the things are as it is. Only stage 1 and stage 2 are interchanged. But for this algorithm, DIFFT, I will consider this as stage 1 and this as stage 2. This stage 2 is same as stage 1 of DIT. This stage 1 is same as stage 2 of DIT. Okay. Question is calculate DFT of this sequence. This is the given sequence using DIFFT. From the given sequence, like the earlier numerical, I will generate the values. X of 0 is 0, first value. X of 1 is 1. X of 2 is 2, x of 3 is 3. These values I have written from the given sequences. For the ready reference, I have written these values. Same like the previous numerical. How to calculate the outputs of different stages? H0, look at the diagram. H0 is output of this adder. So for S0, which lines are connected? X of 0 and x of 2. These two lines are connected and output H0 is generated. So for S0, equation will be H0 is equals to x of 0 plus x of 2. I have written the values. It is 0 plus 2, which is equals to 2. Same way, S1. S1 is output of this adder for which x of 1 is connected and x of 3 is connected. So S1 is x of 1 plus x of 3. Again refer these values. So 1 plus 3 is equals to 4. S2. For S2, which lines are connected? S2 is output of this adder. Which lines are connected? This line and this line multiplied with -1. So it is x of 0 minus x of 2. Again, if you forget this calculation, then simply it is negative of S0. So instead of plus sign, you need to write minus sign. So it is 0 minus 2, which is equals to -2. S3. Again, don't make the mistake. This term contains -j. So S3 will be this line x of 1, this line and this line multiplied with minus 1. So it is x of 1 minus x of 3 and it is multiplied with minus j. So I will write it like this: x of 1 minus x of 3 and this term is getting multiplied with minus j. So it becomes 1 minus 3. I have put the values of x of 1 and x of 3 into minus j. So this is simply 2j, because this is minus 2 and minus of minus become plus, so it is 2j. This is output of stage 1, that is h0, s1, s2, s3. Now final output, that is first output, x of 0. Look at this diagram. For x of 0, what lines are connected? S0, this is first line and second line is s1. These two lines are connected, so it is simply h0 plus s1. So h0 plus s1, that is 2 plus 4, which is equals to 6. Then x of 1. Now don't make a mistake, this is x of 2. I need to calculate x of 1, so I have to think of this connection, x of 1. To calculate x of 1, what are the lines connected? One line is s2 and another line is s3. So simply it becomes s2 plus s3. s2 is minus 2, s3 is plus 2j. So it is minus 2 plus 2j. Next output, x of 2. x of 2 is this line. For x of 2, which lines are connected? h0 and s1 into minus 1. So it is s0 minus s1. So it is 2 minus 4, that is equals to minus 2. Last output, x of 3. For x of 3, which lines are connected? This one line, s2, then s3 getting multiplied with minus 1. So it is s2 minus s3. Again refer the earlier values. So s2 is minus 2 minus s3, that is minus 2j. These are the answers for x0, x1, x2, x3. Now final answer is to be written as a sequence. So the answer is, first answer is 6, then minus 2 plus 2j, minus 2, then minus 2, minus 2j. Same answer we have derived, we have calculated using DIT-FFT. So this is about IFFT. These numericals are pretty simple. You just have to memorize this diagram. That's it. You can solve any numerical. Now the last variation can be asked to calculate inverse DFT, IDFT using the same algorithm. Suppose you want to calculate inverse DFT using DIFFT. Whatever I will be explaining, same logic is applicable, same logic will be applicable for DIT-FFT. Suppose it is asked to calculate IDFT using DIFFT. What are the changes in the diagram? This diagram remains same, only change is that every value will be multiplied with 1 by 4. So I will write it like this: 1 by 4 x of 0, 1 by 4 x of 1, and so on. And one more change is there. Instead of minus j, you need to plus j side. Remaining procedure will be as it is. For example, if you want to calculate IDFT of this answer, then x of 0 will be first value. This is x of 0. So it will be 1 by 4 into x of 0. So this value will be 1 by 4 into 6. That is 6 by 4, which is 3 by 2. Likewise, you will be proceeding. Final answer will be 0, 1, 2, 3. That's it. This is the only possible variation in such type of numericals. So dear students, that's it for today's video. Thanks for watching this video. Thank you very much.